Hello POE and welcome to your solution guide for the fluid power assessment. I am hoping that grades have already been posted or will be posted soon by the time you are watching this video. This is the solution guide, so make sure that you are watching it because in order to take attendance for today, you're going to have to put in the secret password that I will give you in this video. To those of you that have just been looking for it, it is pumpkin. So that is our secret password equals pumpkin. Now, we have got to go into solving this solution guide over here. So for our very first problem, what we are looking for is to make sure that we are labeling our known values. So we know that the diameter of cylinder 1, that is 2 inches. Our diameter of cylinder 2 is unknown, so we are looking for that. We know that the force at 1 is 30 pounds, and the force at 2 is 400 pounds. We don't know pressure. Pressure is one of our unknowns. So we're going to be looking to solve for pressure in this first one. We are going to be using Pascal's law to do so. So that's force is over P times A. We can put this in this nice triangle over here. So we are looking for pressure. So we need to first find our area at cylinder 1, which is going to be our pi times 1 squared, or pi. So we get pressure is equal to 30 divided by 3.14. Pressure is equal to 9.55 psi. Cool. So now we can move on to our next part of this problem, in which we are looking for the diameter of the second cylinder. We are still going to be using the same formula as we did before. We know that the diameter of cylinder 2 is our unknown. We know that the force at 2 is 400 pounds. And we know that pressure is equal to 9.55 psi. So now we can set this up into our equation. We have 9.55 is equal to our force, 400, over our area. So we can multiply area to both sides. Just going to cancel over here. And we end up with area is equal to 400 divided by 9.55. So area is equal to 41.88. That is our inches cubed. Now we need to plug this into our pi times radius squared. So when we do that, we get 41.88 is equal to pi times radius squared. Divide both sides by pi, and then we will square root it. We find that radius, r, is equal to 3.65, but we are looking for diameter. So we multiply that by 2, and we get that our diameter at C2 is equal to 7.30 inches. Cool. So those are our answers for our first two problems. I hope that that cleared some things up for you, or really confirmed that you have got this and you're on your way to mastery. So let's get to mastery. Let's look at problem number 2. Oh, how do I work this thing? Here we go. Cool. So for this one, We are looking to solve for pressure, we are looking to solve for force, and we are looking to solve for flow velocity. So in here, we are given a diameter is equal to 12 inches. We have our flow rate Q in gallons per minute, which is 25 gallons per minute. And we have our horsepower, HP, is equal to 12. We have a 12 horsepower pump. So we have everything to find pressure if we are using our formula that says horsepower is equal to Q times P divided by 1714. So we're going to throw that in. We've got 12 is equal to our Q, which is 25, times our pressure, which we do not know, over our constant of 1714. When we simplify that, we find that pressure is equal to 822.72 pounds per square inch. So we found pressure. Now we are going to be searching for force. We have our diameter is equal to 12. We have pressure, which is equal to 822.72, and we are looking for area. Oh, I'm sorry. We should look for area within this, but we are looking for force. Getting ahead of myself. So we are going to be using Pascal's law, which is force over pressure times area, and our nice little triangle. So in this one, we are going to use our area formula, pi times the radius of 6 squared. We get an area of 11310. So now we can plug that into here. We just need to take our pressure times area, will give us force. So we have 822.72 times 113.10, and we get our final answer to be 92,981.77. That is our final answer, and that's in pounds. Cool. So we are moving through this. We have one more to go. We are looking for flow velocity. And if we go all the way up here, it says flow velocity of the system in inches per minute. So we need to do a transfer, a little calculation here, where we know that 1 gallon per minute is equal to 231 inches cubed per minute. So we want to do a conversion with this. So we already know what our Q is. Our Q is equal to 25. We don't know what our velocity is. That is our unknown. And we know that our area is equal to 113.10.